see the stream go online. Yeah. Okay. I think we are on. Cool. Um, so, yeah. All right. So today, first of all, welcome to Not Crystal Fridays. We're going to do some Go today. I've been doing Crystal programming for a while. Crystal is at crystal-lang.org. And I've been doing Crystal coding, kind of learning Crystal on the fly as I go. Actually, give me 1 second. Let me make sure that that people can hear me. Yeah, all right, cool. Yeah, so anyway, I've been doing Crystal language programming on streams for a couple months. I've been doing a couple of different projects ongoing. We finished one project. Um, I guess that would have probably been about a month ago we finished that project. And then we started another project that was a lot more like, how would you say it? A lot more meaty, I guess. It had a lot more going for it. It was like a web server and it did some downloading from GitHub in the background, and then it tried to unzip the GitHub file, and it's going to go on and like generate documentation for the code and a lot. It was a lot. And so we got, I think, about a halfway through that, I would say. And you can go onto the YouTube recordings and see what's going on with that. So we're probably about halfway through that project. And today I just wanted to mix it up. I wanted to talk about Go. So actually in the banner above, you can actually see it still says Crystal Fridays. I figured I'd leave it for now. If we start doing a lot more Go, then I'll call it Go Fridays or something like that. But if you want to see more Go, I also do Go regularly with Jennifer. Jennifer is on. She's viewing right now. It's her. She is Sig Je. She just put something in the chat. Thank you, Jennifer, and welcome. Thank you for coming. And so me and Jennifer do like Go learning step by step. I think right now we are at the point where we're looking at code. Like we've seen some code, like our first Go program is behind us. And now we're on like our second Go programming. We're going through some more advanced concepts. And I'm super excited for this coming week, because this coming week we're going to start doing some more, I, I'm going to call them really advanced concepts. If you've been doing Go for a ton of time, they probably wouldn't be advanced for you. But you'd be surprised how going back to fundamentals makes a huge difference. I'm talking from experience, because when I'm working with Jennifer, I go back to fundamentals, and I like every stream, I'm like, oh yeah, how does a function work in Go? And it's like you take functions for granted. Obviously, like if you're writing Go or any language, you take functions for granted, absolutely. But then when you have to go back and explain them, then you're like, oh wait, what is this detail? Like how do functions work? How do closures work? How do return values work under the hood? Like all that stuff. It's a trip. It's fun. It's really fun. So um, I will show what's going on with that stream on Mondays. So if you go to GitHub/OSSCDA, click on Let's Go Stream, and that's what the stream's all about. We're also working on a project that we're like slowly but surely expanding out, so you can keep up with our progress there. Um, it's a fun stream. Like tons of people come on the chat, ask questions, make comments. It's just fun. So highly recommend you check it out. Not just for me to get more people on the stream, but also I love talking to folks. Jennifer loves talking to folks too. Me and Jennifer have an awesome time going with our back and forth, talking about Go, comparing it a ton to other languages and other experiences and all that good stuff. It's really fun. Let me go to the chat. Oh, Siva. Hi. Welcome back. Thanks for coming back, man. It's really cool to see you, and I hope we can have a lot more chats in here. And ASW, hello again. Also, thanks for coming. It's really good to have all you here. So let's go into today. Um, Today, I'm going a different direction. So on Fridays, like I do Crystal language programming. I think I've only done Crystal language programming on Fridays, on Friday streams. So this is the first time we're gonna go away from Crystal Lang. I don't know what to call it, but I do know that people call Go Golang. I'm not gonna call it Golang. Just Go. So we're gonna go and talk about JSON today. Um, JSON and Go is kind of done a really specific way. It's like there's the standard library JSON, and then most things are built on top of the standard library JSON. So I'm going to build a web server doing standard library or doing JSON with the standard library. But then I'm going to do that kind of quick. I'm going to like do all the web servery stuff. Like I'm just going to do it. I'll explain it as I go. But then I'll really zoom in on the JSON part. But I'm going to do that stuff like, I'm going to go through that stuff kind of fast because I want to get to this, decode. So if you go to github/go-functional/decode, I'll put it in the chat. github.com go-functional decode. Did I spell that right? I think I spelled that right. Yeah, so if you go into that repo, that is decoding JSON using functional programming in Go. So, okay, let me go into what functional programming means. What does functional programming mean? Well, let's go to the Wikipedia site first. Wikipedia functional programming. So let me just start with the first sentence. And the reason I'm laughing is because like functional programming is, to me, it's like black magic. Like seriously, it's black magic. Just in the sense that like only the like in my mind, like only the chosen few do functional programming, and those are the people that like I seriously like I look up to, because functional programming to me is like all of these math concepts that I love to learn about, I love to read about and try to like apply to my everyday programming. But also it's really hard to grasp those math concepts. And it's easy-ish to grasp the math concepts because it's actually really simple in math. But then to apply it to real programming, that's super hard. I think there's something in my mind that I try to get over in my mind to like apply the math to like the art of programming. And so when I see people who do that on a regular basis, I'm like, oh, you're amazing. So one of them is Eric Meyer, the creator, like literally the creator, one of the creators of C#. I watch a lot of his talks, and he's I mean, obviously he's really smart. He created a programming language that's used by millions of people. But also he gave a talk I watched recently that was talking about functional programming, the math behind functional programming, and then the math behind machine learning. And what I mean by that is he was literally telling us how integers were a functional concept called a ring. Like he was literally saying a number is a functional programming concept. So anyway, I'm rambling. It's just because functional programming to me is really cool, but it's also really hard for me to grasp. So anyway, just going over like what is it? So if you read through this, there's a programming paradigm where it's applying and composing functions, blah blah blah. So I mean, basically, functional programming is when you write programs that are just functions, that only have functions. So it doesn't have classes or structs or inheritance or polymorphism or any of that stuff. It sort of has like polymorphism. Don't really worry about what that is if you don't know. Really, functional programming is the most basic kind of programming. It's just functions. You'll see some of that when I go over this decode library. And we're going to get into it. We're going to get into some functional programming stuff today. But I'm going to get into it without fancy concepts, without fancy math, and with like real code that is followable, that you can actually see how it works. All right. So my rant about functional programming is now officially over. All right, everybody, it's officially over. And so in the chat, Jennifer says, what do you mean by the most basic building blocks? Yeah, I mean building blocks and easy. So building blocks is, what I mean by building blocks is literally there will be like advanced concepts. Like you'll hear the word monad thrown around in functional programming arguments. There's a lot of people who argue about functional programming. You'll hear the word monad and functor thrown around in like textbooks and really hardcore like functional programming, or code bases, repositories that do functional programming. I'm not going to throw around fancy words. I'm just going to show like this is the way this works. I'm not going to say monad or any of the fancy words, because we're going to talk about how a real program works. And so, yeah, and by easy, I just mean we're not going to talk about the fancy constructs or the math or anything along those lines. And then in the chat, Emodome says, people often think that FP has to be illegible. I think a lot of FP tries to make it happen in the least amount of code possible, but you can still be verbose and expressive. I totally agree. Like the least amount of code possible. I mean, it can look terse in some languages. And I find that a lot of languages that are really functional languages make it really terse. One example is the language called Haskell. And Haskell it was initially conceived as an academic language for researching functional programming. And so it's made for really, really advanced functional programming and functional programmers, people who know what all of these terms mean. Higher order functions, where was one here? Imperative, generic, differentiable, flow-based, inductive logic, all this stuff, relativistic programming, automata-based. These are like, that's a language, that's an example of a language that people who understand intimately what all these things mean, what they get, and they know how to read that terseness. But for the rest of us, for the programmers who build only like production level applications, it's not to say that the people who do Haskell don't, because that's absolutely true, they do. But for the people who, like me, who write Go, or people who primarily write JavaScript, who haven't gone into functional programming a ton, they'll probably get first introduced to functional programming maybe without even knowing it. Like in JavaScript, some of the array stuff that you do is taking advantage of functional constructs. So it's definitely a good way to simplify your program. Emodome also, I agree. I really enjoyed Scala, which has pure FP, but also some OO properties. Yeah, I learned functional programming by doing Scala. So I started Scala by doing pure, basically Java in Scala. And then I started doing some functional stuff that's in the Scala standard library. And then I moved into a library called Scala Z, which is pure functional, modeled after that Haskell language I was talking about. And then I started doing some Erlang programming, different programming language that has a lot of functional concepts in it. And then finally, I went to Go, which is very, very oriented towards not functional programming. But I remembered all those concepts. I remembered how much fun I had and how I felt like the programs that I was writing got simpler, at least for me to understand. So then I started trying to integrate some of those functional concepts back into Go. ASW said, I remember when F sharp was, oh, I remember when using F sharp, where a much longer C sharp program might distill down to a nicely readable page of F sharp. Emodome legibility is so important for maintainability. Yeah, I mean, yeah. When you have if you can get to the point where it's like a page of code that another language would take 5 pages, and that page of code is like understandable and readable, and if you're working on a team, it's understandable and readable to multiple people, to everybody on the team, that's a win. Even if you're not talking about functional programming, if it's just you were able to get a large program down into a small program that does the exact same thing, that's a win. So functional programming doesn't have to be all or nothing. You can take bits and pieces and apply them to your code, whether you're doing C sharp, JavaScript, Java, C, C++, Go, which we'll see, really anything. These are concepts you can just pick up one by one or bit by bit and then pull them into your code as necessary. So I hope that you get some of those out of today, and you can take them with you and you can bring them in where it makes sense to you. So we are not going to do the crazy FP stuff today. We're actually going to start with nothing functional. We're going to go into just a blank folder, and we're going to build, like I said, that web server with some JSON. We're going to build it kind of quick, and then I'm going to swap out the JSON stuff that I was doing in the code and try to bring in decode. So let's do it. I'm going to just go to my home directory. Let me make this a little bit bigger. I'm going to go to my home directory and just make dir JSONer. I don't know. JSON stream. Let's do that. I'm going to open it up in VS Code. Let's make this a little bigger. That's a little bit too big. Let's make that. That's good. So the first thing I do in all Go programs that I start these days is I do this go mod init call in the command line. We went over this in the Monday stream with me and Jennifer briefly. We're going to go deeper into it there. But for here, it's basically, I'm going to start up kind of a skeleton of my project. I have to call my project something and pass that to go mod init. And the most common names that you should give your programs are the GitHub name. So I'm going to push this up to a GitHub repo, and I'm going to call it JSON stream. So I'm going to push it up under my org called AR/. And if there are any German speakers here, apparently that's a bad word in German, which I did not know when I first created the handle. So I apologize for that. Please don't hold it against me. But yeah, this is, my GitHub name, and this is the repo. So this is the preferred way. Unless you know about naming in Go and you want to do it differently based on that, use a name like this. So it created it. Going back over to here, this is basically the skeleton. It's the name right here under module, and then the minimum version of Go. And that's pretty much it. And this means like the minimum version of Go that you have to have on your system to build the app. So I'm going to do a new file here. Convention is that your file that's the entry point to your app is called main.go. And I'm going to do a func main. Actually, I forgot something already. I'm going to do a package main. So packages are how you organize your code. So the entry point to your code or to your app looks like this. Package main, and then a func main. And the func main is the code that gets run when your app starts up. So I am going to do a web server, and I'm going to take advantage of just the standard library to do my web server. I don't recommend this. I recommend picking up an actual framework, and I'll do that in a separate stream. We'll probably get to it on the Monday stream too. But for now, I'm going to do a super basic one. And for that, I'm just going to use net HTTP. Whoops. So you see when I press save, it goes away. It's because of the plugin that I have. The plugin that I have automatically detects, are you using it anywhere? And since I'm not using net HTTP anywhere, there's a part of the plugin called Go Returns that automatically detects that. It's an extension to Go called Go Returns. It automatically detects that I'm not using it and then takes it away. By the way, if you want the plugin I'm using, go to your extensions in VS Code, just search for Go, and find the extension that's called Go, and it's from Go Team at Google. This is the one to use. It's like, I'm not going to say the standard one because there's many, but it's the one that's officially supported by the Go team, and it's got tons of functionality in it. So definitely recommend that. So, checking out the docs for it. Go documentation is available for every public Go repository at pkg.go.dev. So like packages, PKG. And then if you don't, you can search for anything, but you can also just append the package name behind, in the path of package.go.dev. So I'm going to go down and I'm going to search for something called serve mux. And here's how you register a path. So I'm saying I want /foo to be handled by foo handler. This one's even easier though. You can do .handle func and then the path, and then just pass a function. This is the function that this handle func requires. So this is like the callback. This is the callback that I want Go to run for me when someone does a curl to /bar. So I'm literally just going to copy this and this down below. This is enough to run a web server in Go. So inside my func main, I'm going to head back over to here. Wow, this is big. I'm going to go down one. If anyone can't see this, throw a message in the chat and then I'll bring it back to the big version. But for now, I'm just going to do this. So we've got our callback, response writer. This is the thing that you'll use to send data back to the client. And then this is the request that comes in. So we kind of already have a functional concept here, believe it or not. So I called it a callback. The functional term for this is called a higher order function. So if you want to go with that and you can sound all functionally, that's cool, but it's a functional concept and a really, really important one to use when you are passing a function in to a function. So I've passed this func HTTP response writer into handle func. So that's pretty cool because you use this all over the place. And there's a fancy term for it, of course, higher order function, but it's really useful all over your code. And if you look, it's just functions. There's no structs or classes or anything like that. There's no inheritance either. It's not like I'm subclassing handle func. It's just that I'm taking a func with my code in it, this fmt.print.fprintf, and I'm just taking the code with my function or my code in it and passing it into another function that I don't control. This is the Go standard library handle func function. I don't control this function. I just know that when I pass my code in, that this handle func function is going to magically call it when someone curls my server to the /bar path. And that's pretty much it. Okay, now let's get some JSON going. So I'm going to have two JSONs going on here. I'm going to have one JSON that I'm going to accept from the client, from my curl or wherever else. And then I'm going to modify that JSON a little bit. And then I'm going to send some new JSON back to the client. So we got two things going on. Accept JSON, return JSON back. Oh yeah, and if anyone saw the last Monday Go stream, I can't remember who told me about the Grub theme for VS Code, but I got it and I love it, especially because look how nice the font looks. I really like the font. It's easier on my eyes. I think the colors are easier on my eyes too, but the font. If you gave me that theme idea, if you pointed me to that theme, put it in the chat so I can say thank you personally. Because yeah, I love it. It's super, super nice. So yes, accepting JSON, and we're going to do the standard library. So first things first, standard library has an encoding/JSON package inside of it. So as you might expect, I'm going to be doing JSON dot stuff. So the first thing I have to do when I accept JSON is I have to define a structure that I want the JSON to get decoded into. Okay, so that's going to be a struct. Request JSON. And I don't know what we're going to have in the body of the incoming JSON. I'm just going to call it an int. We'll just say int1 and int2. We're going to keep it super simple for now. So I'm basically going to build a JSON endpoint that adds two integers together. That's it. Like, it's the simplest thing, but it's good to represent how we're going to do the JSON for now. We'll make it more fancy later on. So we're going to accept the JSON. Now I'm going to write the code, and then it's going to be a slightly longer line, and I'm going to pick it apart one by one so we can see how it works. Actually, I forgot what the function is called. So you'll see me going to this packages.go.dev a lot. This is like the Stack Overflow for Go once you've already gone to Stack Overflow and if they didn't have the answer that you needed, basically. Unmarshal, yes. That's what I was looking for. Yeah, so we're going to do this. We have to create a JSON decoder. And we're going to do a w.header. And one more thing we have to do, request equals new. All right. So let's pick this apart. A couple things going on here. This struct, when I go type request JSON struct, I've created a new type. I'm calling the type request JSON, and I'm saying the type is a struct or a bucket of data. Okay. The struct has two integers, int1 and int2. Okay. So at line 16, we don't have any data yet. We just have the type of data that I'm going to put into a variable. Okay. Line 18, I'm creating a new variable of that type. So request right now on line 18 is the variable name, but it doesn't have anything in it. It just has the space for two integers, and that's it. The reason that I don't have anything in it yet is because that's where I'm going to take the JSON that I decode and I'm going to put it in there. I'm going to put two integers in there. Now the big line, the big kahuna. So we've got two things going on. We've got an if. Okay, so the if is an if, just like other languages. We're going to check to see if a Boolean is true. All right, so now we've got a part before the colon or the semicolon, and we've got a part after the semicolon. So the part after the semicolon is the Boolean. So if we get an error back, the way we say that in Go is if the error is not equal to nil, that means that we have an error. So a nil, when you set error to nil, nil is just, it's not there. It's kind of like null in other languages. Or undefined in JavaScript too. Then before the semicolon, it includes this error colon equals. This is where we're doing the JSON and decoding, and then we're setting the result of the decoding to error. This isn't setting the decoded data to error. It's just saying, did the decode fail or succeed? Okay. Now in the JSON.new decoder, we're passing in something called a io.reader. So right there, if you, let me go to the Go documentation. Decoder right here. We pass in an io.reader. So io.reader is in Go, it's an interface. So an interface, kind of like an interface in Java or an abstract class, similar to an abstract class. So what this is I have an implementation of that interface in the request body. So new decoder is going to decode that interface, or it's going to decode the data in that interface. And it's going to call, we're going to call .decode to make sure that whatever JSON it decoded, this decoder is going to shove the data of that JSON into my request variable. All right. So zooming up to the, or zooming out, zooming not up, I don't think, zooming out into the higher level, we are talking about decoding some JSON right here into my struct, and we're setting the result of that decode, so whether it succeeded or failed, to error, and then we're checking, did we get an error? If we did, then we're going to write a 400 bad request response header back to the client, and then we're going to bail out. All right. Now returning JSON. So I'm going to just add these variables together and call it result. And that's going to be request.int1 plus request.int2. And that is the result. And now we got to create some JSON to return. So we could do another struct if we wanted to. I'm going to do it a little bit differently. So this is the other option. You don't have to do it one way or the other, but I'm just going to show both ways. So we're going to do a map. And I'm actually going to do a new map. And it's going to be a map of string to string. So the key is going to be a string. All the keys are going to be a string. And the value, actually, I need to make the value an integer. And I'm going to call the key a result. And then the value is going to be the actual result. Okay, so the JSON that comes back is just going to look like this. If I passed up 1 and 2 as integer 1 and integer 2 up here, then it's going to be 3. So that's literally what I want the JSON that gets returned to look like. All right. So how do we encode the JSON back? Well, it's going to look really similar to this line right here. But instead of a decoder, we're going to do an encoder. And encoder also takes an io.writer this time, not an io.reader. So I mentioned a bunch earlier. I mentioned back at the beginning of the stream earlier that the HTTP response writer is how we write back to the client. So HTTP.responseWriter happens to be an implementation of io.writer. So we just pass it straight in to new encoder. Now, instead of decoding, we're going to encode, and we're going to encode the return map. All right. And by the way, this ampersand, if you haven't seen it in Go before, it's taking the address of return map. So this whole thing, if you don't want to talk about taking the address, instead we can just say ampersand return map is the pointer to the return map. So I don't have time to get into pointers today. Jennifer and I will do a pointers episode in the future. I promise. But if you don't know about pointers, you don't want to think about pointers or something else about pointers, that's cool. Just remember, if you're calling .encode, you always have to pass ampersand return map. Yeah, Jennifer says it's cool. I'm holding you to that. You should hold me to that. Absolutely. By the way, the pointers episode in Go is going to be super fun because Go has pointers like C and C++ has pointers. But there's one part about Go pointers that makes it 10 times simpler to get than the C version of pointers. And it also makes it a lot less prone to blowing up your program, which is really nice. So Jennifer, I'm so excited to talk about pointers. Can we like short circuit all of our other topics and like go into pointers like right away on this coming Monday? I'm sort of kidding. We don't have to do that, but I would have a lot of fun talking about pointers whenever we get to it. Okay. So I'm pretty sure, yeah, you have to pass a pointer here. And again, this is saying, did we have an error encoding the JSON right there? Okay, so if we did, then we need to write header again, a failure. I'm going to choose a 500 internal server error because I don't think that's anyone else's fault but my server if we couldn't encode the JSON. And then at the end of the day, for Go, if you don't return, if there's a code path where you don't return a body or a header, then it automatically assumes it was a 200 OK, an HTTP 200 OK. But there's another case where here, this is the success path, right? I want to decode it up here without having an error. So I want to skip over this. I want to keep going down here. I want to do my addition. And then I want to encode the new JSON back to the client. I want to skip over this. And down here by line 31, this empty line, I have now returned data to the client. And the first time you return data to the client, Go will automatically assume it's a 200 OK. So this pattern is the best pattern to do if you're cool with sending a 200 OK back to the client. There would be cases where you're like, well, I want to send like a HTTP 201 created back to the client. So all you have to do for that is this. You just put the header, you put the right header call just before you return any data to the client. Okay. So I'm not going to do that. I'm good with a 200 OK. And basically now my code is okay. I'm going to do one more thing. Is it print F starting server? We're going to do starting on port 8080. We have what is this called? A twang, I guess. I don't know. I like saying starting server. It sounds more fun to me. So you can tell it's Friday. I'm all over the place with this Friday. We're gonna start in the server. Let me go to the chat real quick. Oh yeah, Jennifer reminds me we're gonna talk about doing serverless functions with Go this Monday. We've got a guest. ASW 101 is gonna actually be on with me and Jennifer. It's gonna be 3 of us. We're gonna be talking about Go serverless functions. It's gonna be super fun. That's my plug for Monday. I've been plugging Monday quite a bit over the past 10, 20 minutes. But yeah, I'm super looking forward to that. Oh yeah, Jennifer, you plugged it too with all caps. It's the best right there. Yeah, Emodome says serverless plus Go is great. You know, I haven't actually run serverless Go like in production. I've built like little samples. I've played around with it, but like I want to build an app one day that has no serverless. But I want to do it with Go. Like I want to build an app that's like just like a Vue or React front end and like serverless Go and not have like, VMs or anything like that. Because building the serverless stuff is a different mindset. But anyway, I digress. And by the way, if you do serverless Go, you don't have to do this, any of the http.listen and serve. And you don't have to do this most of the time. You just write this, the business logic. I'm going to call it business logic. You just write that. So let's go run our server. What would you call this? Server full This is a serverful, not serverless, like the opposite. If you've got a better name for it, let's hear it in the chat. I'm calling it serverful for now. So I'm going to run it. Starting server on port 8080. I like it. So we're going to head over to a new tab and we're going to start curling some stuff. So 8080, and let me remind myself what the path was. I called it /add. And we have to do, we don't have to do a post request, but I'm going to do a post request. And I'm going to pass in, that's how you do a post request in curl. And I'm going to pass in some JSON, and it's going to be called int1 and int2. And that would be int1. I'm going to pass 1 in for that, and int2. And I'm going to pass 2 in for that. We're going to shut down the JSON. I put a weird backtick there. And let's see if it worked. Hey, it worked. Just for my sanity, let's do 2 and 3. And even though it's Friday, I know my math still. I can still do addition in my head. Most Fridays I can't. So this is going to be 5. I'm impressed with myself. Maybe you all are too. I don't blame you if you're not. But I'm impressed with myself. This is 5. Awesome. So we've got something working. Super cool. So this is kind of the anatomy of a server in Go. Compared to other languages I've worked with, I feel like this is a pretty easy way to do it. Like I said, you can get fancier. You probably should if you're doing like a production grade server where you need higher level features. One example I was just mentioning is you might need to restrict this and make sure it's only a post request. That's a thing that's probably a good idea, especially if you're doing APIs, like JSON REST APIs. But basically, this is fine. Like, this is good enough for a demo. This is even good enough for, like, if you're writing a quick production app. This is production grade code. Especially, like, it's not production grade because I did something, interesting. I didn't. It's really production grade because of this HTTP handle func. And also at a higher level, it's because of this net/HTTP. There are some really smart, talented, accomplished, smart people who have written the code behind net/HTTP. And I'm talking about smart because they know HTTP well, but also smart because they know how to build APIs well. And I'm saying that because when they built this API and down here at the HTTP listen and serve API, they built it only with HTTP 1 in mind. So that's the really tried and true HTTP that's been around practically forever. But they were able to add seamless and transparent HTTP 2 into the mix without changing anything at the API level. So that's pretty cool. Like, you can completely change the underlying implementation, but keep the API the same. That's like, in my mind, that's like the holy grail of APIs. So I'm really happy with that. I'm really impressed with that because I just can say, hey, my new API is modern. It's got the most modern web standards, HTTP2, JSON, fast, all that great stuff. So anyway, pretty cool. I like it. So let me go back and let me talk about JSON some more. Okay, so we've got the standard library. There is a different way I could have done decoding, and that is with this, Unmarshal. So Unmarshal takes in this data parameter. The data parameter is a slice of bytes, so that's what this means. Bracket, open bracket, close bracket, byte. So that's a slice. It's called a slice in Go, kind of like an array in Java or a list in Python or an array in JavaScript. What other languages do I remember this? I think it's called a vector in C++ or vector in Java. I don't know. You probably get the idea if you've written languages that are similar to these. It's a list that you can expand or contract of bytes. So you can do bracket string or bracket anything really. But this function, this API takes in a bracket byte, a slice of bytes. It also takes in an interface. An interface is like any. Well, it's like object in Java. It's like it can be anything. It can be a pointer to anything. It can be anything, literally anything. So it could be a byte. It could be a slice of bytes. It could be an integer. It could be your own struct. It could be literally anything. Okay. So what this is saying is pass in any bytes. So this is not an io.reader. It's bytes. And then that's the JSON. That's like the raw JSON that's going to be decoded. And then you pass in your thing, and it will be decoded into your thing. Okay, so whether you're using Unmarshal or you're using newDecoder.decode like I did, how does it know what to decode into? Okay, now this is like, obviously this is a really important question because you have to know like how to specify the structure of the JSON you're expecting. But it's also like this little tiny detail of the Go syntax that actually tells the program, tells your decoder or your unmarshal function what it should expect in the JSON. So right here, these backticks are how you do it. So what I'm saying here is in my struct, I've got an integer that I'm calling int1, and I'm calling that the variable int1 in Go. But over here with my backticks, I am telling the Go JSON decoder that I want it to expect lowercase int1 in the JavaScript. So there's a difference here. There's uppercase int1 and lowercase int1. I can rename this and call it the first integer. I can rename it to whatever I want. And it will still expect the first integer in JavaScript. In JSON. It'll take the value in JSON of that thing, say that fast. The first integer. It'll take the value of that, and then it'll put it into this, the .int1 that I used down over here. Okay. These things with the backticks are called struct tags. Okay. They're called struct tags because literally you are adding a new annotation or tag to int2 or int1 or whatever struct variable you're talking about. And they're called tags because it's literally like tags in a GitHub issue or labels in Gmail. You can have many of them. You can tag a struct variable or struct field, as they're called in Go. You can tag it with as many of these tags as you want. So you can do JSON. You can add a tag for what the database field should be called. There's tons of tags out there that different libraries support. This library right here happens to support the JSON tag. Okay. Now, if you do this the other way and you make a struct for encoding request JSON, then it will use these tags to figure out what should the JSON fields be when it outputs, when it makes the JSON to send it back. Okay. So the tag is used for two things: when the JSON comes in and when the JSON goes back out. So it's like, I say these are they're kind of out of the way, I guess, just because it's one little detail right here that determines how your JSON should look. But if you think about it in terms of putting the definition of the JSON next to the data that's actually going to be in your Go code, in my mind at least, it makes it click a little bit because I don't have to think about where am I defining what the JSON should be and then how's that matching up with the actual variable in Go, because they're right next to each other. So I really like that. It makes it a little bit, a little bit less cognitive overload, I guess. Maybe that's the best way. I'm not sure the best way to put it, but maybe that. Let me see in the chat. Is it like JSON property and then putting a name inside of it for mapping JSON fields. I think you're talking about Java. I think. I remember a library in Java. I can't remember what it's called. You probably remember though, Siva. I think that's Java, and yes, I remember that. That would be, yes, like an annotation on a field in a class that is saying to the Java JSON library, I want you to call it this. And so that's the same principle. It's like, if you don't see the chat, oops, it's like saying this. Int1, int, but then putting above it JSON property name equals the first int. So it's, yeah, it's just like that. It's just the Go way of doing it is a slightly different syntax. But yes, exactly. You got it. So, okay, we ran the thing. And we curled it twice. And my math in my head was right. So that's a win on the day. I am actually going to cut this stream off in 8 minutes at 11 a.m. my time. The reason is that a colleague is doing an awesome stream that I'm super excited about that I think you should go to. So I'm going to raid that channel in a little bit, not yet. But let me start down the path of functional JSON, using functional programming concepts to do JSON decoding. Okay. I'm going to go over to my decode repository, and I'm just going to talk about why this thing exists. Okay. Actually, let me just show the API first. The API looks a little bit like this. Okay. There's a lot going on here. Just check out the first one here. So let me actually copy this in so there's not so much distraction. So, and I'll put it on different lines. So what this is saying is I want to take a JSON dictionary that looks like this. Oh, I can't type. So I want to take a JSON dictionary that looks like this, and I want to drill down into it to figure out what snow, not show, to figure out what the precipitation type is. So this is like a weather API that I'm kind of simulating. But basically, I want to drill down into what the precipitation type is. So basically, I want to get snow. This would probably be like snow or hail or fog or rain or something like that. So if you did it with the struct here, request JSON, you would have to make a struct inside of a struct. So you'd have to do like type weather struct and then minutely. And then you'd have to do another struct that's precip type. Like that, just to get out snow from here. So that's okay. It's not the biggest deal in the world, but what would be nice, oh yeah, and you have to do the struct tags. And then you gotta do JSON precip type. So that's fine. If you can imagine like, something that's deeper than this. If it was like precip type and then it had another dictionary under it and maybe that had another dictionary under that, you can kind of imagine it getting really deep. There are APIs that get really deep. Like if you look at the Stripe API, it can get pretty deep, like 3 levels deep, or in other words, 3 dictionaries deep at certain places. So if you have that, then with the standard library, you have to do all the structs. So it's a lot of kind of boilerplate. So this decode library that I kind of just made it as a hobby to try out some functional programming things. This decode library is really geared towards drilling down to one value. It's not geared to like something like this, to like grabbing a bunch of values out of a JSON body. The standard library does that great already. This one is geared towards just drilling down to get one value that's pretty deep down into a bunch of dictionaries in some API. So this is how you use it. This is how you would do this JSON dictionary up here. It's kind of like JSON path if you're familiar with JSON path. But either way, even if you're not, this is saying first go to the minutely, the dictionary under minutely. So that's this. Then hit up the precip type key. So that's right here. And then take the value of that key and put it into a string. So that's saying, I want you to take the value of precip type, so snow. I want you to expect it to be a string. And then I want you to write that string into my variable, which must be a string. Okay, so this is how you make a decoder. So that's kind of like only this part, not the .decode part, but just JSON.new decoder. Okay. This is as far as we're going to get today, but I promise we're going to pick this up. You know what? Let's do this next week. Let's do some more Go next week, and let's pick it up right here. Because this is I mean, I wrote the library, but I copied all the concepts of the library from somewhere else. I think it's really cool because of that. I'll explain where I copied the ideas from next time, but I think it's really cool because of this concept. I mean, the library, the code is like alpha quality code. I'll show some of the code next time as well. But what I really like is that this library copies a really powerful functional programming concept that we'll show off next time. So yeah, let's do this again. Go on Fridays. We're going to continue doing JSON decoding using functional programming concepts. Same time, same place. 10 a.m. US Pacific time. This very URL that you're on, twitch.tv/ARSCHLES. And if you're on YouTube, head over to arschless.com/about. And you're going to want to look under Crystal Fridays. I'll have to change that to add some Go goodness as well. But you can check out twitch.tv/ARschless if you want to come live next week. But also, all of these on YouTube links. The Monday stream, the Wednesday stream that me and Jennifer also do, and then down here. If you click on any one of those, you can see the playlist for each of the recordings. So like this one will be up soon after Twitch does its thing. All the other ones are up and will be up in the future too. So if you want to go back and learn some Go, that's this one on the Monday one. If you want to go back and check out this one again, obviously that's an option too. So I am going to raid Eric's channel, eric.dev. I just learned this too. I'm newish to Twitch. What that means is that if you stay on here, you're going to get thrown over to his stream. He is doing a stream with some NVIDIA folks on, it's over my pay grade what he's doing. I know he's doing some embedded stuff with, I think it's video decoding or face detection with video decoding. I'm not sure, but you have to go to find out. I'm going to go to find out too. So here goes. Yeah. And if you don't want to if you don't want to be part of the raid, you basically, yes. Okay. Jennifer says what it is. Jetson embedded devices, deep stream, and intelligent edge. Thank you, Jennifer. That one slipped my mind. All of those things are slightly above my pay grade. And yeah, it's with NVIDIA folks and NVIDIA embedded things. So, like I said, yeah, it's above my pay grade. I don't know how any of this works, so I'm going to check it out too. So we're going to do the raid. Let's try this. Raid eric.dev. Yeah. All right. So if you're still here, we are about to raid. It's going to be in like 1 second. All right. Here we go, all. I will see you next week. Bye. Bye.